Good. Next is Mohammad Hossein Moradi from KIT. The floor is yours. Thank you.
That's perfect. Good afternoon, everyone. Let me introduce myself. I am Mohammad Moradi from the Institute of Internal Combustion Engines, Karlsruhe Institute of Technology. And today I will present you our joint work with WinGD related to the application of reinforcement learning for marine route optimization. First of all, let me start with the motivation. In order to achieve the CO2 target in 2050, the ship industry must be optimized in several aspects. The different approach must be considered in these parts. For example, the engine efficiency can be must be increased, or the hydrodynamic properties of the hull must be improved, or the most important approach for this project will be also the optimization of the route in order to, for example, avoid rough sea conditions and saving the fuel consumption. In the several studies, they have analyzed, they have applied different methods for this application, means for optimizing the route of the ships, among others, and the most important of that is the dynamic programming. A lot of previous studies have applied dynamic programming, but we are, as the title of this project say everything, we will use the reinforcement learning. But what is the advantage of the reinforcement learning over the dynamic programming? The RL is the model-free method, which means that it can be also used to explore larger environments, and additionally, it can also it allows us to have a continuous action space. For the case study of this project, we have analyzed about 700 kilometer part of the route between the New York and France, about 700 kilometers. We have also applied the generic ship models with typical feed-forward neural network, and according to the real data. And for the analyzed route, we had to generate the grid system that you can see in the pictures below, right? And the grid system means that different points that each point has a specific coordinates, GPS coordinates, and also we had to call the weather data through an API from the database. If I say the weather data is also the time-based and dynamic parameters, which means that in the time of the voyage will be changed permanently. And in order to fulfill the Markov properties, we have applied and we have three parameters there. Besides the longitude and latitude, we have also applied the time as a third parameters for our state space to fulfill the Markov properties. And as our action space, and for example, in the discrete formats of our work, we have also the ship heading and the ship speed. And for discrete format, you can see in the right side, it is so that the agent is able to choose between, for example, in this case study, between 5 different points, and also can choose also the speed profile. of the ship. And in this way, it must be choose the best way to save the fuel consumption or to avoid the rough sea conditions. And the primary results from our study shows that it's able to save up to 4% fuel consumption in the case study, in the analyzed case study, with only a small deviation compared to the great circle. Great circle is the is the direct line that the most ships are used normally. I have also listed some important summary and outlooks of our projects. And as an example, this 4% saving of the fuel consumption, if you want to have a sense about it, if all the ships worldwide could achieve such a reduction in the fuel consumption, it will be equivalent to it is equivalent to the yearly CO2 emissions of the Switzerland. And we have also planned to have another methods in these parts, namely DDPG and PPO, to also allow the continuous action space, and we expect more fuel consumption reduction by using the continuous action space. Furthermore, we want also to have a simultaneously optimizing the route optimization and the energy management system as a multi-agent reinforcement learning, and to consider all the parameters simultaneously. Thank you very much for your attention. Please feel free to contact us if you have any comment or question on our project. Thank you.
Thank you, Mohammad.